Since automotive air conditioning was introduced, it has become an increasingly popular option. In fact, most of today's Buick owners take it for granted. Air conditioning systems have been improved for increased efficiency and reliability over the years. And when they do malfunction, diagnosis and service doesn't have to be a big problem, if you use the right diagnostic procedure. Before you can diagnose an air conditioning symptom, you have to verify the customer complaint. To do this, you must understand how the system is supposed to function. And that means first identifying the system you are working on. Buick uses 4 different types of air conditioning system controls: a manual system, the graphic control center used in the Riviera, and 2 types of electronic touch climate control, or ETCC. One uses an LED temperature display, and the other uses a numeric temperature display. In addition, there are 2 basic types of compressors: a cycling clutch compressor used in the CCOT system, and a variable displacement compressor used in the VDOT system. Cycling clutch compressor systems control the amount of cooling through engagement and disengagement of an electromagnetic clutch. The variable displacement compressor also has an electromagnetic clutch, but it does not cycle on and off to control cooling. Instead, cooling is controlled by varying the displacement of the compressor. The VDOT system is used with smaller displacement engines because the changing engine load created by constant clutch cycling would noticeably affect drivability. In addition to these 4 basic types of controls and 2 basic types of compressors, Buick uses a number of different actuator systems. The charts in your know-how reference manual will help you to identify the system you're working on. The specific diagnostic procedures vary from system to system, but some basic rules remain the same. As with all diagnostic procedures, you want to make the best use of your diagnostic time by performing the easiest procedures first and eliminating as many possible causes of a problem as you can with each procedure. This checklist in your know-how reference book will help. Also, use the checklist when performing an air conditioning checkup and give a copy of the results to the customer. It's in a separate section of the book so that it can be reproduced easily. Begin any diagnosis or checkup with functional checks. These will verify the customer complaint, if any, and reveal any additional problems. You may even find the cause of a problem in the course of performing these simple procedures. At this stage, you can also use the self-diagnostics available with the ETCC and graphic display systems. If the functional checks don't lead you to the cause of a symptom, a visual inspection might. Again, these are quick procedures that can often reveal the source of a problem without extensive testing. If a visual inspection doesn't indicate any obvious problems, then you should proceed with performance testing of the system. Analyzing the results of your performance test should help you to pinpoint the cause of the problem. A leak test is only necessary when previous diagnostic steps have led you to suspect a leak. Yes. If so, you may have to perform more than one type of leak test. Following this overall strategy when diagnosing air conditioning problems will help you find the cause of a symptom as quickly as possible. Let's look at each type of testing individually. The first step in air conditioning diagnosis, once you've determined which system you're working on, is function testing. We're using a car with manual controls and a CCOT system to demonstrate here. But the procedures are similar for other control systems and are included in your know-how reference manual and in the appropriate section of the Buick Chassis Service Manual. First, check to see that the blower motor operates properly at each speed. If it doesn't, check for a blown fuse or faulty wiring. If there is no problem with the blower, reduced airflow may indicate a restriction in the evaporator. Check the system in each mode and at all temperature settings to make sure that hot or cold air flows from the proper outlets. If it doesn't, the problem may simply be with an actuator. For example, a complaint of insufficient heat with the controls in the maximum heat position on LeSabre's and Electra Park Avenues with manual controls can result from failure of the actuator for this slave door, which should close whenever the system is in the heat or defrost modes. If the door stays open, it allows some air to bypass the heater unit and reduces outlet temperature substantially. One cause can be a large vacuum leak or a disconnected vacuum supply line. Another possible cause is a disconnected actuator vacuum line. Incidentally, this slave door was a late design change in 1987. Additional information on the slave door can be found in this bulletin and in your know-how reference manual. Other actuator problems, besides insufficient vacuum, include mechanical problems such as misadjusted cables or rods and bent or misadjusted air doors. On some systems, actuator problems can also be caused by malfunctioning electrical or electronic control units. Simple logic can reduce your diagnostic time when trying to pinpoint the source of an actuator problem. For example, if air fails to flow from the panel outlets with the manual system in the vent mode, you can be fairly certain that the problem is not with the cable-actuated temperature control. It is likely to be caused by a pinched or disconnected vacuum hose. An under-hood visual inspection is another way to quickly pinpoint many causes of air conditioning problems. Begin by checking for leaves or other debris blocking the condenser. Also, check the radiator and condenser for visible signs of damage, and check for blockage in the area between the two. Visually, check for leaks or damage to components. Oil deposits at obvious leak points may indicate a refrigerant leak. But don't forget that a small amount of seepage at the compressor shaft seal is normal. With the engine running at 1,000 RPM, set the air conditioning controls in the normal mode and at the coldest setting with the blower on high. Open the hood and vehicle doors and place an auxiliary fan in front of the vehicle. Touch the evaporator inlet line and the accumulator. They should be about the same temperature. If the inlet line is cooler, the refrigerant charge is low. You should refer to the partial charge procedures in the Buick chassis service manual. Check for frost on the lines. This indicates a restriction, which is acting as an orifice and allowing the refrigerant to evaporate before it reaches the evaporator. Frost on the line after the orifice tube may indicate a blocked tube. This is because the small amount of refrigerant getting past the blockage is under low pressure and is evaporating immediately before it reaches the evaporator. On CCOT systems, check to see that the compressor clutch engages properly and that it is not slipping by observing it for 2 or 3 cycles. And check that the electric cooling fan comes on. If the fan or the compressor clutch fails to operate, check for obvious causes like burned out fuses and burnt or disconnected wiring. One simple test you can make on the clutch is to jump it to ground and to the hot battery terminal. If it engages when powered in this way, the problem is not in the clutch itself. And you can check the operation of the electric cooling fan motor in the same way. Don't forget that a low refrigerant charge will cause the pressure cycling switch to open and prevent the compressor clutch from operating. Even if the compressor clutch cycles properly and the drive belt appears to be in good condition, check the belt tension. You'll find the specs in the maintenance section of the Buick Chassis Service Manual and in your know-how reference book. If your visual inspection doesn't reveal the source of the problem, you'll have to proceed with performance testing. If the system charge is low, you must add refrigerant until the inlet line and accumulator are approximately the same temperature before performance testing. To performance test the system, you'll need 2 thermometers, an auxiliary fan, and an air conditioning manifold gauge set. Begin by connecting the gauge set to both the high and low sides of the air conditioning system. Stabilize the air conditioning system by setting the controls for maximum cooling with the blower on high and running the engine at 2,000 RPM for 5 minutes with an auxiliary fan in front of the condenser. Place 1 thermometer in front of the condenser and the other in the center AC discharge outlet. record the thermometer readings and the manifold gauge readings, and compare them to the specifications in this performance chart found in the Buick Chassis Service Manual or in your know-how reference manual. The procedures are much the same for graphic control center systems. However, there are some differences in the way you set the controls when performance testing. Also, you must compare your pressure gauge readings with the system sensor readings to make sure the sensors are accurate. When performance testing VDOT systems, you must also check the operation of the internal regulator in the compressor. Remember that in extremely hot and humid weather, even a normally operating system may produce fairly high discharge temperatures. Some customers may simply expect too much from the air conditioning systems, especially under extreme conditions. Don't forget that high humidity puts as much extra load on the system as high ambient temperatures. If you have detected a low charge, leak test to determine if a system leak was the cause. There are several methods of leak testing, and it may be necessary to use a combination of them to locate a leak, especially if it's a small one. All leak testing should be performed in still air with the engine off. Sometimes a red dye is included in the refrigerant charge at the factory to make leaks more readily visible. Using a clean cloth to wipe suspected leak areas like connections and couplings will reveal any dye which has escaped. R12 with red dye or fluorescent dye is also available in the aftermarket and can be used to detect leaks in the same way. One of the most effective methods of detecting leaks is one that has been around for a long time. A solution of soapy water or one of several commercial preparations applied to suspected leak areas will usually make it possible to spot even the smallest leak. Finally, electronic leak testers are available, which will detect freon gas. Follow the manufacturer's instructions for use, and remember that refrigerant gas is heavier than air, so the probe should be held under suspected leak areas. As with your visual inspection, remember that a small amount of seepage at the compressor shaft seal is normal and may be enough to set off the leak detector. You can also use a leak detector to locate leaks in the evaporator by removing the resistor in the evaporator case and inserting the probe into the case. If the air conditioning system has been opened to the air, it will have to be evacuated and charged. If the system has been contaminated with metal particles from a seized compressor or with other foreign matter, you will have to flush the system. We'll cover the procedures for flushing and recharging using disposable cans of R12. The procedure is similar when using large drums of refrigerant. If you are using a charging station, follow the manufacturer's instructions, with the exceptions noted in the Buick Chassis Service Manual. After discharging and evacuating the system, begin the flushing procedure by adding 2 pounds of R12. Do not use any other type of refrigerant for this procedure, or you could damage the system. Run the engine at idle for a minimum of 5 minutes with the air conditioning controls in the max AC mode and the blower on high. You can then discharge the system. Begin by slowly connecting a gauge hose to the low side service fitting on the accumulator, with the other end of the gauge hose inserted into an uncapped refrigerant oil bottle. As the hose is tightened, refrigerant will begin escaping into the bottle. If it doesn't, the Schrader depressor in the hose fitting may be defective or missing, and you will have to use another hose. With the system completely discharged, check for pressure at the high side fitting, located on the liquid line or on the muffler. Presence of pressure at the high side fitting indicates a restriction on the high side of the system, which must be corrected before evacuating and charging. When discharging is complete, measure and record the total amount of oil collected. If it is more than 1/2 fluid ounce, add oil to the system as described in the Buick Chassis Service Manual. Now remove the orifice tube and re-inspect it. If some contamination still exists, thoroughly clean it. If needed, a new orifice tube should be installed. Also, install this inline filter kit. There are 2 types available depending on the vehicle application. Both kits come with complete installation procedures. You can then proceed to evacuate the system. First, check the low pressure gauge and vacuum pump. The gauge should read 0 when disconnected from the system. If it does not, tap it lightly to make sure the needle is not just sticking. If necessary, adjust the gauge according to the manufacturer's instructions. Once the gauge is properly calibrated, check the vacuum pump by connecting it to the gauge and running it. It should be able to generate the specified minimum vacuum for your local altitude as indicated by the chart in your reference manual. If it doesn't, check the pump system for leaks or mechanical problems as described in the pump instructions. Hook the low pressure gauge to the low side service fitting on the accumulator. When using disposable cans, attach the tapping valve as described in the manufacturer's instructions. Then, attach the center hose of the gauge set to the refrigerant source, in this case, the can of R12. Attach the hose from the high pressure gauge to the vacuum pump. Start the vacuum pump and slowly open both the high and low side valves on the gauge set. Continue evacuating the system until the low pressure gauge reading is within specifications for your local altitude, as indicated by this chart in your know-how reference book. Close the high side valve on the gauge set, turn off the pump, and watch the low pressure gauge for 5 minutes to make sure that the vacuum holds. If it doesn't, you'll have to leak test, repair any leaks, and repeat the procedure. Charge the system by first running the engine until it reaches operating temperature and setting the air conditioning system controls to the off position. Open the valve at the refrigerant source and allow 14 ounces of liquid R12 to flow into the system. Set the air conditioning controls to normal and the blower to high. Using an auxiliary fan to keep the condenser cooler than the charging cylinder temperature will speed up the charging process. Add the specified amount of R12 indicated in the Buick chassis service manual. Close the valve at the refrigerant source and run the engine and AC system for another 30 seconds to clear the lines and gauges. Disconnect the low side hose from the fitting at the accumulator. Never remove a line from the gauge set itself while the line is still connected to the AC system. Replace the protective cap at the accumulator low side fitting and shut the engine off. Charging is now complete. You'll find more detailed information on air conditioning diagnosis in the know-how reference manual that accompanies this program. But the important thing to remember is to use your diagnostic time to the best advantage. Begin with the easiest procedures, like function checks and visual inspections, which may reveal the cause of a problem. Proceed to performance testing and leak testing only when necessary. You'll find that many air conditioning problems can be corrected easily and quickly the first time. That way you can keep your customers cool and satisfied.